ready to get you planning the experiment. So what are you going to need to change on purpose? That's your independent variable. You're changing the mass of the car. What's going to change as a result? What are you measuring during the distance that the cup traveled? So let's think about some constants here for this experiment. This gives you a rough estimate of what it's going to look like, but let's take a closer look. So you will get a kit of supplies. In your supply kit, sorry about the jumpy video, you will have your cup with the garage door cut out, your car, yay, piece of Hot Wheels track, some painter's tape, that's really handy, and your small weight. So these items are in your container. You're going to set this up with the Hot Wheels track on your stack of books. It has a nice blue tab here. I've found that if you take the blue tab, you tape it down to the book, that's going to keep your angle constant. That's going to start it in the right place every time. You'll also need a runway. You're actually going to be marking up the runway and measuring to distances that you mark on here. So notice that I have placed my ramp on my low mass mark because we'd start with our small mass car. So there's a lot of things you're going to want to think about as constants. The ramp would be a really good constant. You want to keep the same surface. Obviously the paper has a different amount of friction than the table, than the carpet out in the hallway. So angle of ramp, surface that you're testing on, the way you release your car. Right now, holding this on top of the ramp, it's not going to accelerate because the forces acting on it are balanced. As soon as I release my hand, now gravity becomes an unbalanced force to take it over. It's going to keep going because of friction. So the way that you release your car would have an impact on your data. So would the car that you use. So you want to use the same car every time. So considering all of that, some constants. You want to use the same ramp angle. You want to use the same surface so it has the same amount of friction. You want to use the same car. You want to release it the same way. All of those things are going to be kept the same to keep your experiment fair. So how are you actually collecting your data? Well, it's explained here, but I'll also show you real quickly. For your first set of trials with your low mass car, you're going to put your cup at the end of your ramp. You're going to point your car forward. You're not going to push it, you're just going to release it and gravity will take over. And then you want to record where the front of the car ended with an X. So I'm going to put an X, and this is my first trial, so I'm going to put a 1 next to it. Now I'm going to set my cup back at the start. I'm going to release my car. That's trial 2. Mouth is right here, real close to my first data point, X and 2. Put my cup back, put my car at the top, release it again. That's going to be trial 3. Gosh, my data points are really close together. Yours might not be that close together, and that's okay. So now I have my 3 data points. But I'm going to estimate my average, which is kind of like the middle child of my data points. So if I had to average where these guys are, boy, it's real close to this, this data point. So I'm going to put an A right here. Just about approximating halfway between my shortest and my longest, pretty close to my second, so that's going to be my average. Now, I need to move my whole setup over, so I'm just going to take my piece of tape up. I'm going to move my ramp to high mass. To increase the mass of my car, I'm taping it to the top so it's nice and secure. You have some painter's tape, and you have a little weight to put in your car. When you tape this on, you want to make sure you don't tape to the wheels, because if you tape to the wheels, they don't work very well. So you don't want any tape covering the wheels. But you're going to tape your mass on. You want to make sure you get it good enough. Okay, dude, this is really hard to do with no hand, with only one hand. So hang on. So I want to get a good enough tape job that it's not going to fall off, but I don't want it to stick to my wheels and impede the way my car operates. So I have that on. You guessed it. Do the same thing. Put your cup at the bottom. Release your car. Whoa, now I noticed that my cup tipped up and my car went right under it. So I'm going to repeat that trial because I don't feel like I got good data there. So release your car. Now I'm going to record the distance my car moved. This is an X. This is trial 1 for my high mass car. Place it back. Set it up again. Alrighty. I'll place an X. Label that too because that's my second trial. You can already tell increasing my mass is increasing the distance my cup travels. I got one more. Alright. So now I put an X for 3 for my third trial. Lift up your cup, look at your data points. I'm going to approximate where my average seems to be, about right here. That's my A. Now I need to graph it. So you're going to graph it 2 ways. First of all, I need to measure my distances using my metric ruler from the start to each of my data points. So for my low mass car, I'm going to put my distance for trial 1 in, distance for trial 2, distance to trial 3, and my distance to my A. I'm going to do the same thing for my high mass car. One thing to think about when you go to get your average distances here, you're not going to consider this guy for your average distance. You're just adding the 3 numbers you actually got. So you're going to add your 3 numbers that you actually got and divide by 3 for your average. Don't include this one when you go to sum up for your averages. So now I have a graph here that actually shows how far my cup traveled, and I can use this data and the graph in my notebook to show the relationship between mass of sphere and kinetic energy. You can tell though, just looking at this graph, at my low mass versus my high mass, sure does seem like my high mass car had a lot more kinetic energy and was able to travel a lot further. So collect your data and then graph it on the next page in your notebook. Good luck.